Now that we've looked at all the properties of logarithms and exponentials and how they look visually on the graph, what we are going to be doing is solving equations for logarithms and exponentials. So any kind of equation with the logarithm or exponential in it, we're going to be looking at how to find out what the unknown variable is. So the main things that you need to be able to do is use inverse operations all the way through. The newest of inverse operations that we have are logarithms and exponentials. So, multiplication, division, we know how to undo that. Multiplication or addition and subtraction, we know how to undo those. So it's just really that logarithm and exponential relationship that we're trying to look at. And then also we need to do it in the proper order. So that's objective number 2. We're going to just go straight to working out examples. And remember, PLMDAS is always our guide for this. So I'm going to write that. All right, and the very first one that I'm going to do is number 6. Your set 1 through 6 is not only asking you to solve these exponential and logarithm equations, but it's also asking you to recognize just the steps and being able to recognize different forms of answers. So number 6 looks like this. All right, and what they do ask us to do is determine whether the x values are solutions or not. And off to the side, they have these different possibilities for answers. All right, so what I'm going to do is just start by solving this equation. And once again, this is in parentheses, so there are no addition or subtraction outside of parentheses. There is no multiplication or division outside of parentheses. There is a logarithm going on, and its inverse is an exponential. So I am going to undo that. So here I have the natural log of x minus 1 is equal to 3.8. So in order to undo this logarithm of base e, I'm going to take it and make these both exponentials or exponential expressions base e. That natural log and that exponential base e cancel each other out. I get x minus 1 is equal to e 3.8. So now I would add 1 to both sides. This is something that you could do in your calculator at this point. So type that into your calculator, and what you would find is not only is this one, of course, if I were to just take those terms and change the order of them, this is yes. This part A, yes, is a solution for x. Part B, when you do this in your calculator, yes, it is a solution. So you would have to type that all in. Use your E button. You have that available to you. C is no. Okay, there's nothing in this solving process that would have led me to C as being a solution. One example that we will look at also is number 4. So once again, they set us up with possible solutions, and we have to determine which ones are solutions. Alright, so I'm going to go through the process of solving this. I am going to undo, I have to write it again down here, sorry. I have to undo an exponential base 5, so I'm going to use a logarithm base 5. Alright, so those cancel each other out as inverse functions do. I have a 2x plus 3 is equal to a log base 3 of 8, 12. Oh, I'm sorry, log base 5. Bad handwriting. Alright, at this point I would subtract 3 from both sides.